This one asks us to solve 2x plus 4 greater than 0 and 4x greater than 0. We treat the inequality sign as if it were an equal sign and essentially solve for x here. So let's do that. So in this, we have 2x plus 4. I'm going to subtract the 4 from both sides. That gives us 2x greater than negative 4. Dividing by 2 gives x greater than negative 2. Okay, and then on the other side here we have 4x greater than 0. We just divide both sides by 4. That leaves us with x greater than 0. And this is still an and in between. So this is really what we're working with here. X greater than negative 2 and x greater than 0. Let's move to graph notation and look at this solution set. X greater than negative 2 is all the numbers bigger than negative 2. So here's 0, negative 1, negative 2. Since it's not greater than or equal to, it's just greater than, we have the parentheses instead of the hard bracket, and we're going off to the right here. Something like this. Okay, so it's all the stuff bigger than negative 2, not including negative 2. Okay, for x greater than 0, well, that's all the numbers bigger than 0, but not including 0. So here, I'm going to start right at 0 and go off to infinity like this. And again, we could also do this as open circle like that. Pick your favorite. Okay, but remember, and is the overlap. And is always the overlap. So look at these two. We have these two shapes going off, these two lines going off to infinity, but we only want to cover where they overlap. The overlap is only 0 to infinity. It doesn't include this stuff between negative 2 and 0. So there's the graph notation of the solution set. For interval notation, we want to transcribe this graph into the interval notation. So we want all this information from this graph to go down into our interval notation. So what I see in this graph is it starts at 0, so 0. I'm doing a soft bracket here because it doesn't include 0. Okay, and then it keeps going. By keeping going, we represent that by a comma. So this comma here says all this stuff in between, basically, is what this comma means. And then where do we stop? Well, this graph never stops. So down here in interval notation, I'm going to put infinity, meaning we just keep going forever. There's our interval notation. And that's usually how we represent these answers because the graph notation is so cumbersome. These are the same, these mean the same thing, but look how much more compact the interval notation is. Let's try another one. Here we have negative 7x less than or equal to negative 21 and x less than 20 less than or equal to negative 15. Okay, so let's see here. First we'll quote-unquote solve for x. We treat these inequalities like they were equal signs and solve. But there's one big difference. Here we have negative 7x. I'm going to divide both sides by negative 7. But when we do that, we have to change the direction of the inequality. So we're going to change it from less than or equal to greater than or equal to. Okay, so if divide across an inequality by a negative, change the direction. Of the inequality. All right, and that's in red because it's important. And this actually works if you multiply too. Okay, so that's something to keep in mind. So what does this leave us with here? We have x greater than or equal to 3. Okay, for the second one here, we just have to add 20 to both sides. Note, nothing to change on the inequality. It only works for multiplying and dividing is where we change the direction of that inequality. So here we have and x is less than or equal to 5. Okay, let's go to our graph notation. Graph notation is good for now, and then eventually that's something we want to leave behind and just focus on the interval notation. So there's our number line. Let's do 0, 1, 2, 3, 4, 5. So here's 3, here's 5. Those are the numbers I'm interested in. So this first bit here says x is greater than or equal to 3. Okay, so greater than or equal to means we need to include the point 3. I'm going to use a hard bracket to show that we're including 3 and going up, like so. So it just keeps going off to infinity. And, okay, the second one here says now we're doing all the numbers less than or equal to 5. Okay, so that starts us out at 5, and then we're going down to negative infinity. So down this way. But and is the overlap, right? So where do these two overlap? Only between 3 and 5, right? That's where the two overlap, leaving us with a final answer, an interval notation of just this region in between. For our interval notation, we want to translate that down into interval notation. We want to represent everything on this graph, but in a more compact form. Well, let's see. It starts at 3. I'm using the hard brackets because it includes the point 3. Then this comma means all the stuff in between, and then we have a 5 where it stops. Hard bracket again because it includes the point. There's our interval notation, 3, 5.